topic is axiomatic approach to probability. It is defining the probability of event. In this method, there are some axioms or some rules to depict to indicate the possibilities. So here for that, let us take in a random experiment, S is the sample space and P, the probability P is a real valued function with domain, its domain of P is nothing but power set of S. Okay. So here P is a real valued function. S is the sample space. In a random experiment, S is the sample space and P is the probability. Probability P is the real valued function. Here domain is nothing but power set of S. And range is closed interval 0, 1. Okay. Then let us see what are the rules. Axioms are for any event E, probability of E greater than or equal to 0. Okay. That is probability of any event should be greater than 0. Okay. Greater than or equal to 0. Next, probability of S is equal to 1. That is probability of sample space. Okay, probability of a sample space is 1. Next, if E and F are mutually exclusive events, these rules are very important. If E and F are mutually exclusive events, then probability of E union F is equal to probability of E plus probability of F. Okay, remember these are very important. If E and F are mutually exclusive events, then probability of E union F is equal to probability of E plus probability of F. Therefore, see here, it follows that probability of phi is equal to 0. Why? Because let us see, let us take an event E, probability of E union phi. We know that E and phi are mutually exclusive since their intersection is null set, right? E and phi has no elements. E has any elements, so when we take the intersection, its intersection, so we will get no element, no common element, right? Therefore, we know that it is clear E and phi are mutually exclusive events. So, according to this, if E and F are mutually exclusive events, probability of E union F is equal to probability of E plus probability of F. So, probability of, here also we can apply this method, that is probability of E plus probability of phi, right? That implies, see what is actually probability of E union F? That is nothing but E itself, right? E union F is, E union phi is nothing but E itself, right? Because phi has no elements, so when we take its union, we will get E itself. Therefore, here we can write probability of E union phi is nothing but probability of E, that is equal to probability of E plus probability of phi. That implies, see when we take this one here, so we will get probability of phi is equal to 0. That is probability of in an empty set, that is 0. So next rule, next axiom is the sample space containing outcomes omega 1, omega 2, omega 3, etc. omega n. Okay, so omega 1, omega 2, omega 3, etc. omega n are the elements of or the outcomes of the sample space. Okay, here we have taken these are the outcomes of the sample space. Then we can write probability of omega I. Okay, that means all the sample space. Okay, probability of any sample space in probability of outcomes in sample space, that is between 0 to 1. Okay, 0 less than or equal to probability of omega I less than or equal to 1. That means probability of any outcomes in sample space is between 0 to 1. And next is probability of omega 1 plus probability of omega 2 plus probability of omega 3 plus etc. plus probability of omega n, that is equal to 1. Okay, so what are the omega 1, omega 2, omega 3, etc., omega n? It is nothing but these are the outcomes of the sample space here. Okay, therefore here probabilities of all the omegas. Okay, sum of probabilities of all the omegas, that means all the outcomes in the sample space is 1. Sum of probabilities of all the outcomes in sample space is 1. These are the important axioms of this probability. One more axiom is, for any event A, probability of A, that is equal to probability of sum of probability. Okay, sum of probability of omega I. Here all omega I belongs to A. Okay, so when we go to examples, you will understand it more. See, it is the last axiom. For any event A, probability of A, that is equal to sum of probability of omega I. Here all omega I are in A. Okay, so first I will write once again. First one, for any event A, probability of A, for any event E, probability of E greater than or equal to 0, and probability of sample space is equal to 1. Then if E and F are mutually exclusive events, then probability of E union F is equal to probability of EU plus probability of F, and it follows that probability of phi is equal to 0. After that, sample space containing outcomes omega 1, omega 2, omega 3, etc., omega n. Then there, that is probability of those outcomes in sample space is between 0 to 1. Okay, that is the values of probability of those outcomes in sample space is between 0 to 1. And for any event A, and its a sum, see here, that is probability of sum of probabilities of all the outcomes in sample space is 1. That is sum of probabilities of all the outcomes in sample space is 1. And for any event A, probability of A is equal to the sum of probabilities of all the elements of A. Okay, that is sum of probabilities of all the elements of A. Now let us go through some questions. First one, a coin is tossed twice. What is the probability that at least one tail occurs? When a coin is tossed twice, the sample space is HH, HT, TH, TT, right? Now here the given event is, see, event is at least one tail occurs. The event is equal to at least one tail occurs means, see, what are the elements? At least one, so greater than or equal to 1. So HT, TH, TT. Okay, T should be greater than or equal to 1. So HT, TH, TT are the elements of E. So here we have to find the probability of this event, right? So what is the probability of that at least one tail occurs? That means we have to find the probability of this E, event E. Therefore, probability of E is equal to, see, our axiom is for any event A, probability of A is equal to sum of probability of omega I. Here omega I belongs to A. That means that is the sum of probability of all the elements of A. Right? So here that is probability of E is nothing but probability of HT, probability of TH, probability of TT plus probability of TH plus probability of TT. That is our, it is the our last axiom, right? For any event A, probability of A is equal to, here that is sum of probability of all the elements of A. Here omega I belongs to A. Okay. So here probability of HT plus probability of TH plus probability of TT. See here what is the probability of HT? See, number of possibilities, that is only HT is only 1. So 1 out of 4. See, there are how many elements in sample space? 4. Therefore 1 by 4. Its probability is 1 by 4 plus its probability is 1 by 4 out of sample space 4 elements. So its possibilities, number of possibilities 1. So plus 1 by 4, that is 3 by 4. So 3 by 4 is the probability of that probability that at least one take occurs. See the next question. A die is thrown. Find the probability of following events. The 3 events are given. A prime number appear. A number greater than or equal to 3 will appear. Third one, a number more than 6 will appear. Okay. So here when a die is thrown, the sample space is, what is the sample space? S is equal to 1, 2, 3, 4, 5, 6. Right? Okay. Now let us write the events. See, first one is a prime number appear. Let an event be A. A prime number appear. What are the prime numbers? 2, 3, 5, right? 2, 3, 5. So, what is the probability of A? Okay, same axiom we will apply here. That is for any element, any event A, probability of A is the sum of probabilities of all the elements of the A, right? So, here probability of A is nothing but probability of 2 plus probability of 3 plus probability of 5. That is here probability of 2, see, only once it will occur. So 1 by, out of how many elements? See, sample space. In a sample space how many elements? 6 elements, right? So 1 by 6 plus 1 by 6 plus 1 by 6, that is 3 by 6, that is 1 by 2. So 1 by 2 is the answer of first one. That is here probability of event a prime number appears is 1 by 2. Okay. Next one, a number greater than or equal to 3 will appear. Let this event be B. Okay. B is equal to, let us write the elements. A number greater than or equal to 3. Okay. Greater than or equal to 3 means the numbers from 3 to 6, right? So 3, 4, 5, 6. So here probability of B is nothing but probability of 3 plus probability of 4 plus probability of 5 plus probability of 6. That is 1 by 4, not 4, 6, right? See how many elements are in sample space? 6. So out of 6 plus 1 by 6 plus 1 by 6 plus 1 by 6, 1 by 6. That is 4 by 6. That is 2 by 3. So its probability is 2 by 3. Next is a number more than 6 will appear. See, there is no number more than 6 will appear when a die is thrown, right? See here in sample space up to 6, right? So there is no number. That means this event is an empty set. There is no element in this event. Let this event be C. So here empty set. So we can write it as empty set. So what is the probability of the empty set? Probability of 5. Probability of an empty set is nothing but 0. Okay, its probability is 0. Look at next question. A card is selected from a pack of 52 cards. First question, how many points are there in the sample space? Calculate the probability that the card is an ace of spades. Calculate the probability that the card is first one an ace and second black cards. See here, the pack of here selecting a card from pack of 52 cards. Obviously there are 52 elements in the sample space. Okay, that is, see how many points are there in the sample space. Sample space means, see what is the number of elements in the sample space. That is nothing but 52. Okay, that is number of sample space, that is equal to 52. So next question is, calculate the probability that the card is an ace of spades. See, there is only here the event is given, the event is card is an ace of spades. Okay, so here the probability is, see, first of all we have to check how many elements in this event. Okay, so here card is an ace of spades, so there is only one ace of spades. Therefore we can write the probability of, first of all let us write the event. Let this event be A, is the card is an ace of spades. Okay, there is only one ace of spades out of 52 cards. So we can write probability of A is equal to 1 by 52. Okay, because there is only one element in this event. Because there is only one ace of spades. Next, here calculate the probability that the card is an ace. Here the event is, the card is ace and black card. It is not together, okay, separate question is. So here we can write the card is ace. See, there are 4 ace cards out of 52 cards. The probability of this event is, probability of B is nothing but 4 by 52. Okay, that is 4 by 52 is nothing but 4 ones are, yes, 1 by 13. Right? Okay, next see another question, black card. Okay, so what is the probability that the card is black card? See, there are 26 black cards in out of 52 cards. Okay, there are 26 black cards out of 52 cards. Therefore, we can write the probability of this event. Let us write this as C. The card is black card. So, there are out of total 26 black cards. Therefore, probability of this event is nothing but 26 out of 52, that is 1 by 2. Okay, so its first question answer is 1 by 13, second one 1 by 2. The next question is, there are 4 men and 6 women on the city council. If one council member is selected for a committee at random, how likely is it that it is a woman? So here the total number of members in the council is 4 men plus 6 women. Total members in the council is 4 plus 6, that is 10. Okay, so one member is selected for a committee out of 10 members. One member is selected out of 10 members is 10C1. That is, out of 10, 1 is selected, that is combination. 10C1 is nothing but 10. So here number of sample space is 10. So here we have to find the probability of the selected member is a woman. Okay. So there are 6 women in this council. Okay, one is selected. Therefore, it is the event. Let E be the event. E be the event. The member is a woman. So here total how many members? 6 members, right? 6 women. So out of 6 selecting 1, that is 6. Okay. So here what is the probability of E? So probability of E is nothing but number of elements in this event is 6, right? Number of elements in the event is 6. So 6 divided by number of elements in the sample space, that is 10 total. So 6 by 10. So here 3 by 5. So 3 by 5 is the probability. See next question. If E and F are events such that probability of E is equal to 1 by 4, probability of F is equal to 1 by 2 and probability of E and F is equal to 1 by 8. So find probability of E or F, probability of not E, not F or not F. So here what are given? Let us write what are given. Probability of E is equal to 1 by 4, probability of F is equal to 1 by 2, probability of E and F, that means probability of E intersection F is equal to 1 by 8. So find probability of E union F. E or F means probability of E union F. So we know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So probability of E union F is equal to probability of E plus probability of F minus probability of E intersection F. It is the formula for probability E and F are any two events. We know that if E and F are mutually exclusive, then probability of E union F is equal to probability of E plus probability of F. So because it's 0. So here it is the formula probability of E union F is equal to probability of E plus probability of F minus probability of E intersection F. So let us substitute here 1 by 4 plus 1 by 2 minus 1 by 8. So it is 4 plus 2 divided by 8 minus 1 by 8, that is 6 by 8 minus 1 by 8, 5 by 8. 5 by 8. So first question answer, it is nothing but 5 by 8. Probability of E or F means probability of E union F, or means union and means intersection. Okay. So next question is probability of not E or not F. That means probability of not E means E complement, okay, E complement, or union F complement, okay. That is nothing but probability of E union F whole complement. That is nothing but 1 minus probability of E union F. Okay. Probability of E complement union F complement is probability of E union F whole complement. That is equal to 1 minus probability of E union F. That is equal to 1 minus probability of E union F is minus 5 by 8. So 3 by 8. So second answer is 3 by 8. Next question. In a class of 60 students, 30 opted for NCC, 32 opted for NSS and 24 opted for both NCC and NSS. If one of these students is selected at random, find the probability that the student opted for NCC or NSS, the student has opted neither NCC nor NSS, the student has opted NSS but not NCC. So here there are total 60 students. So out of 60, one is selecting, right? So our number of sample space is nothing but 60. 60 C1, that is 60 itself. So next is, see, here let us take, let A be the event. Let A be the event that the student is selected for NCC, okay, selected for NCC, and let B be the event that selected for NSS. Okay, so here number of elements in A is nothing but number of A, that is equal to 30, because 30 opted for NCC, and number of B is nothing but 32, and it is given that, see, 24 opted for both the NCC and the NSS. Both the NCC and the NSS means that is common. Okay, so common in NSS and the NCC. So total we can write it as A intersection B, right? That is number of A intersection B is equal to 24. Now let us find the probability of this. That is probability of S is 1. Probability of A is equal to 30 divided by 60, that is 1 by 2. Total 60, that is number of elements in sample space. So next here probability of B is equal to 32 divided by 60. 4 8s are 4 1s are 415. Okay. So next probability of A intersection B is equal to 24 by 60. 12 2s are 12 5s are. Okay. So here we have got probability of A, probability of B, probability of A intersection B. Our first question is the student opted for NCC or NSS. That means the probability of all the students. Okay, that is NCC or NSS. So all the students. That means A union B, right? So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. That is 1 by 2 plus 8 by 15 minus 2 by 5. So LCM is 30. So here 15 plus 16 minus 30, right? Okay, 12 divided by 30. That is 16 minus 12, 4. So 19 by 30. So here we have got first question. Answer is 19 by 30. So next one is the student has opted neither NCC nor NSS. So how can we write neither NCC nor NSS? That means see probability of A complement intersection B complement, because neither NCC nor NSS. Okay. So here the students selected for neither NCC nor NSS means A complement. Okay, not A, not B. Okay. Therefore A complement intersection B complement. So probability of A complement intersection B complement, that is nothing but probability of A intersection B complement. So we can write 1 minus probability of A union B, that is 1 minus 19 by 30, that is here 30 minus 19, that is 11 divided by 30. So 11 by 30. So next is the student has opted NSS but not NCC. That means NSS means B, right? Yes, B. So here we can write probability of B but not NCC. So in the section A complement. Okay, that is nothing but probability of B minus probability of A intersection B. Okay, that is probability of B is 8 by 15 minus probability of A intersection B is 2 by 5. So here 15 is the LCM. So just multiply here 3. So 24 minus, sorry, not here, 8 minus, here you have to multiply 3. So 6 divided by 15, that is 2 by 15. So 2 by 15 is this answer. Okay, that is student has opted for NSS but not NCC means NSS means B, right? Okay, B. So B intersection A complement.